things were happening.
You need to see the end.
I know. I went back and I saw some things, but yeah.
Hey, so today is
Things
Friday,
conspired.
Friday, January 19th. We've taken a long hiatus due to holidays and, illnesses like COVID, which are happening these days.
We had holidays, we had COVID.
But we are back with, what is this episode? This is episode 2 of season 2. Hey, Josh.
Hey, Eric, how's it going?
All right.
Okay, so I've been preparing for a class that I'm going to be teaching, Introduction to Neurophysiology, and I've been focusing on dopamine, and it's based on my original research on dopamine that I've already talked about a little bit. But as I've read all of the other people who've been working in the field, I thought I needed to address some of what they've been talking about.
I'm sorry, I just want to step back. What is the name of the course?
Introduction to Neurophysiology.
Is this a course you've taught before?
No.
Oh, fascinating.
This is not a course I've taught before, and
that.
I am not teaching the way the course is normally taught. I'm not using a textbook.
Well,
I'm making it all up.
One of the that's one of the things I like about this. Is that when you do a new course, you have to decide what you're going to do and learn it. And do
exactly.
It yourself.
Yeah. So normally when someone would do a new course, they would pick the textbook and then the syllabus would follow the textbook. But instead, I have a bunch of ideas and then I have to find papers that follow those ideas. And I have to do this for undergraduates, which is a little bit complicated because some of the papers are for, say, postdoctoral students.
Yeah.
And others are more for an introduction to high school students. And in between there is some things my students can actually read and learn from. And it's difficult to find exactly what they are.
This is great. It's making you do a lot of work.
It's making me do a lot of work. And then the other problem is I disagree with the fundamental model of dopamine as it is presented. And so the readings I have are all about what that fundamental model is, but the actual lectures are going to be something else entirely. So this is going to be unusual for the students, reading something that then the professor is arguing against. So if they study and learn what they're reading,
this is for undergraduates?
Yes, it's a little difficult. So what I'm doing,
I was an undergraduate. I have a lot of respect for undergraduates and the work that they do, but this is very different. Do you think they can handle it?
I hope so. Mostly it's going to be listening to me and I explain it to them. And then the background reading, which they wouldn't do anyway, is going to be...
Okay.
Sorry, honestly.
All right.
So they were going to be listening to me anyway and reading my notes. That's all that they ever do anyway.
So this is interesting. So maybe after they come in once or twice and they hear you arguing against something that they have not read, they might get interested enough to actually then...
They might, but I will also be explaining that as well. So they just want everything given to them, honestly. And I will be doing that. And I'm happy to do that. And if they need to do any extra studying, I will have provided papers for them in the field.
And will you give them opportunities to show that they've done that work?
I will be testing them, and they will have to know some things.
Excellent.
And then they will be making a poster and presenting it. So anyway, what my research had shown is that dopamine is not a stimulant, it's inhibitory. And that's what started everything. And I tried it a bunch of different ways, and it was quite conclusive. However, there's no one in the field arguing it is or isn't a stimulus. They're just accepted that it's a stimulus, and let's move on. And now let's talk about what dopamine does. So they've left behind the whole part that I'm actually disagreeing with. And so there's a new understanding of how dopamine works. Dopamine had been understood as a reward substance. It is now no longer understood as the thing that makes you feel good. It is understood as the thing that makes you want to feel good, not the thing that makes you feel good.
And this is as of when? When did this change?
It probably started in the 90s, but it has become more and more accepted through the 2000s. And so this is mostly coming out of a group of people called affective psychology. So affect.
With an A, not
with an A, exactly. So these are people who are behavioral psychologists who are studying facial expressions in response to things. And in this case, what they're just looking at is, do you stick your tongue out and dislike something, or do you suck heartily on the thing and enjoy it? And so it could be cocaine or it could be sugar. Those are pretty much the two things they use, mostly sugar. And what they've shown is that rats or people like sugar even if they have had all their dopamine blocked. So a rat who has had their brain surgically altered so that they're not producing dopamine will happily suck on sugar water and or cocaine. And someone with Parkinson's disease who is not producing dopamine will still enjoy the taste of sugar water. They'll say, yes, I like that. It tastes sweet.
So the idea here is that with dopamine, with no dopamine at all, you can still enjoy things.
Yes, exactly. And people who have low dopamine and are depressed and can barely get out of bed still feel pleasure. So there's a difference between the idea of pleasure and wanting something. And so the model now is that dopamine is the stimulant that causes you to move towards a reward. And it's the thing that makes you want the reward, and it's the measurement of the reward. So this is the current understanding.
Wait, it's both the pre, meaning the thing that stimulates you to move towards the reward, but yet it is also the measure of the reward received?
But not the reward, yes. And so I find this confusing.
But how can it be something before you receive the reward and then also after you get? It's both.
It's both, and it kind of has to be both.
Okay.
What I have problems with the idea of something being a measure of a reward, but not the reward itself. And so the studies show that if you block dopamine in a rat, it falls flat on its face. It's not going to move anywhere. It has no desire to go anywhere ever again because it wants nothing. But if you actually
so the idea being that it would literally lie there until it died.
Yes. But if you put sugar water in its mouth, because it doesn't want anything, it has no buildup of wanting because it has no access to dopamine. But if you put sugar water in its mouth, it sucks happily on the sugar water. So it doesn't know it wants the sugar water, but it enjoys getting the sugar water. So this is a separation between liking and wanting. And I think this is an overly complex model. And I think it misses the fundamental nature of what dopamine is, which is an inhibitory reward substance, not a stimulatory substance that makes you want something. Something that would be inhibitory wouldn't encourage wanting in the same way, whereas something that's stimulatory also would then be a problem when you've finally got the reward, because it would make you move away from the reward because it's stimulatory rather than staying there. And so my model of dopamine is essentially based on the carrot hanging in front of the donkey. And I've said this before, but now I understand exactly what's going on a little bit more. So the ancient Greeks, when they thought that vision worked by having little objects go into your brain or into your eyes, and they would actually be sitting in your eye. And so now we understand that obviously there's nothing going into our eyes from the outside.
They actually believed that there was a physical thing going into your eye, which
in some way.
We know that there is, but not the way they thought.
Not the way they thought, or that maybe something was leaving your eyes and then sending it out and then information was coming back to it. They had all sorts of ideas because they didn't understand how anything worked. And this is obviously not how vision works. However, if you think of an organism living in the water, trying to find something, it's going to be using smell. And smell and taste, if you're sitting in the water, are essentially the same things. And so smell and taste are little bits of the thing you want. So it's a little bit like the original Greek understanding of vision. To see something, perceive it with your taste smell in the water, you're actually going to get a little piece of that thing you're tasting, smelling, in order to know you're looking for the right thing. Okay, so my whole model is based on that. And so let's say there's some food in the water and there's little bits of amino acids. The number one amino acid that we all respond to is glutamate. So monosodium glutamate is the thing that makes you taste things as savory as meat. There's only 5 flavors. 2 of them are rewards, sweet and savory. 2 of them make babies and rats stick their tongue out and frown, so sour and bitter. And then salt sort of depends on how much salt you have. Both the glutamate and the glucose can go through the brain-blood barrier and can directly stimulate reward pathways. We don't know exactly how all of this works. More and more I'm finding out if I don't know something at this point, it's because it probably hasn't been known. I'm not boasting that I know everything in the field. I just keep running into these walls that just find out that we really don't know these things because it hasn't been tested. So
the models have a black box.
They have things. So something you like goes in, sugar or glutamate, and your brain says, suck that down, eat it up.
Essentially, yay, more.
Yay, more, exactly. And so the models of how what they call appetitive behavior, appetite-stimulated behavior works, is that you have a lack of something, you feel uncomfortable, hungry, or sexually aroused. You really, really want to go find a reward. By the way, a lot of this modeling was done by men, so sex is a lot of sort of the metaphors that people are using. Sex definitely has a desire, and then a very, very obvious reward moment, and then you're no longer desiring for a while, and then you slowly become more uncomfortable as you're seeking it again. However, I think food is a better model for this. One, because there are things that don't have sex that still need to eat. Food comes prior to sex in evolution, and unlike sexual release, when you're eating, you still need to have some of that desire. The desire and the eating are happening at the same time. Mm-hmm, mm-hmm. So it's a more complicated system, and I think it's more fundamental.
It's a more inherently complicated system. Yes.
Yeah. So the idea is you haven't eaten, you want food, you then seek out food. You get food signals. You get excited because you get those food signals. You seek out that food. You get the food. You're getting rewarded, so you hold still and eat that food. And at this point, you're sated and you don't look for food anymore for a little while. Mm-hmm. And then the whole system repeats itself. Yeah. Okay. So in my system, that glutamate would go through the water. Glutamate directly stimulates a little bit of dopamine. And so the dopamine, this is known.
It enters through into the bloodstream, right into the brain, and
yes.
Boom.
And this would be not just for a crayfish and shrimp, which I was studying, but also for a human. You actually get glutamate going into your brain when you eat it.
Right, from my mouth
to your brain.
Right to the brain.
Right to the brain, exactly. So these are conserved pathways. So in evolution, when we talk about something that you see everywhere, this is a well-conserved pathway. That glutamate stimulates dopamine. What does that dopamine do? It says, let's keep looking for more of what we're getting. We want to find more of this food. So a crayfish in the water will move towards a gradient that gives it more glutamate in one direction.
I sense a little glutamate. Over here, I sense less. No.
Go towards the good thing. Yes.
More. Yes. Tuning in a radio station.
So every time they're going in the right direction, they get a little bit more reward, the dopamine.
Yeah.
So this is my model now.
Yeah.
Okay. So imagine you have a donkey running after that carrot on the stick. Mm-hmm. Okay. So the donkey can see the carrot, but in this case, there's no vision. Mm-hmm. So this is basically a donkey looking for a carrot on a stick, getting little bits of carrot. Tiny little bits of carrot.
Tiny little bits.
And as long as it keeps getting tiny little bits of carrot, it knows it's going in the right direction. It gets no carrot, it stops, it goes in the opposite direction. So my understanding of what researchers have been doing to the rats when they block dopamine is they've been blocking those little bits of carrot. And so that little, donkey mouse, crayfish, doesn't get those little bits of carrot, and so no longer goes for the carrot.
There's no hope.
There's no hope. There's no point to it. What dopamine does, in my opinion, and somewhat the research supports this, is it signals that there is hope, there is something to go for.
Yeah.
And then the dopamine goes directly to both reward centers and places in your brain where it is converted into epinephrine, adrenaline, norepinephrine, all basically the same thing. So the dopamine directly becomes a stimulant.
Which is in itself a reward, is it not?
It's related to rewards.
You feel energy.
I suspect these are related to the dopamine rewards, and that the energy is there to keep you moving. So that you get a little bit of dopamine, you don't say, I'm done. I say, I want a bigger reward. I'm being given dopamine, so I'm in a constant real-time measurement of I'm going in the right direction. Mm-hmm, I'm aiming for the right thing. Mm-hmm. And I'm getting stimulated a little bit by that epinephrine so that I keep moving.
So then what happens once you get that meal and you get the big payoff?
Okay, once you get the meal, now you're getting a major reward. So you're getting more dopamine.
Yeah, like all at once.
All at once. And I think there are other things that are happening as well. So part of the reason that people think that dopamine is no longer a reward, but it is just a thing about wanting, is measuring wanting.
Yeah.
Exactly. It's just confusing to me.
Yeah.
Exactly. How much money do I have? It's the money in my hand. This is like something like not the money. It's some sort of measurement of money, but not money.
Yeah. It
anyway,
doesn't make sense.
For me, the money
the way
is the
you
measure
say
of the
it.
money.
Yeah.
Yeah. Anyway. So there are opiates and there are cannabinoids. These are the two molecules that directly signal liking, as the afferent, as the psychologists call it, not afferent, but the affect of psychologists.
Mm-hmm.
So there's wanting and there's liking. And so dopamine makes wanting, in their opinion,
Mm-hmm.
and the opiates and the cannabinoids make liking.
Mm-hmm.
Okay, so I think both sugar and glutamate and various drugs are signaling the liking things in these two very small pleasure areas. Dopamine tends to, it signals in a much larger area called the nucleus accumbens. It's underneath the brain, essentially. These other two smaller ones are in it, and they talk to each other. So the two smaller pleasure centers make dopamine, and the dopamine signals these pleasure centers. So what you do, if you block dopamine, you can still feel the opiates and the cannabinoids. So I'm not denying that. I agree with that. So you can actually block dopamine and still have liking. Dopamine, because it's also a reward, in my opinion, is the measure of the reward because it's how much dopamine you make. When you're stimulating the opiates and the cannabinoids, they're also releasing dopamine. So they're also saying, yes, you got that reward. So that reward is the measure of the reward.
So the opiates and the cannabinoids actually not only turn into epinephrine, but they also create.
Dopamine turns into epinephrine, and they signal more dopamine to be created.
So dopamine is coming and going.
Dopamine is coming and going, and all of these things talk to each other. It's why I don't deal with people much, because all of these centers are signaling each other as well, and a lot of them are black boxes. This is all done with functional magnetic resonance imagery, and so it's correlation, not causation. We just know there are correlations with certain things that we call liking that happen in these pleasure centers, that happen if you directly inject opioids into these pleasure centers, you get the liking.
But it's fascinating
phase.
Because you have the two that you meant, the cannabinoids and the opiates are specific, but the way you describe it, the dopamine is a more generalized thing that affects more. So if you were to shut that down, the sense of like being certain that there can be no satisfaction.
Yes,
I cannot, and then once something stimulates the cannabinoids and the opiates, then but then once it stops, there's
still nothing
again.
again. Exactly.
Hope. And you're certain,
right? And you're certain, exactly, because all the little carrots have been blocked. Right, all those little carrots that shrimp gets have been blocked.
Well, having done none of the reading, the way you describe it, it sounds
perfectly reasonable. Exactly, yes. So small amounts of dopamine are known as what's called tonic dopamine, as in muscle tone. So if you remove tonic dopamine, you have no muscle tone. You just collapse. You just have nothing. And so this constant supply of small rewards in the form of tonic dopamine are also stimulating epinephrine, keeping you moving towards that reward. And then the opioids and the cannabinoids are the sort of really obvious liking signal, but dopamine itself is a liking signal. The liking signal gets stronger in the presence of dopamine, but without dopamine, you can still like it. So again, dopamine is liking and is wanting because you want a reward. Now think about what these things are. I'm including dopamine with opiates and cannabinoids. All three of these things, in my opinion, are not stimulants. They are inhibitory. They're not inhibitory and then they stop something, but when you get them, you stop moving. Right? You stop seeking the thing you're looking for because you've been rewarded.
Except the dopamine, which you said.
Very small amounts of dopamine keep you moving, but a large reward, you sit and eat the food pellet, right? So the crayfish stops looking around. even though there's a lot of dopamine in the water near it, right? It can smell dopamine, but it's getting the dopamine. It's also getting the opiates. It's also getting the cannabinoid because it's found the right thing. These things respond to a whole bunch of different chemicals, particularly the cannabinoids respond to a bunch of fatty acids. And so the crayfish has found its food and stopped moving. But when it's looking for food, it's not getting little bits of cannabinoids and it's not getting little bits of opiates to tell it where to go. It's getting little bits of dopamine. So dopamine is the direct measure of small amounts of things that you want to cause you to seek that thing. So bright lights, flashing colors, good smells, nice sights, things you are attracted to. That's all measured by dopamine. But it's also rewarded by dopamine in conjunction with these other reward molecules. In the current model, dopamine would be a stimulant, they would be inhibitory because dopamine is not a reward. In my opinion, dopamine is a reward and is just like these other ones. In large amounts, when you get the reward, you stop moving. It would be really interesting to see if you can cause liking in the absence of opioids and cannabinoids. This has not been done.
With only
dopamine, right? So because you can block dopamine and you can still see that there's liking in the presence of these other things. It hasn't been done in the other direction. What I have found in my research that has not been done elsewhere, that I'm realizing is important now that I've been going over this stuff, is I have shown wanting when dopamine is blocked. Now, I've shown this in a short term. So I can give something glutamate, and it acts just like there's the smell of food in the water. So it's exactly the same.
Without dopamine.
Just glutamate. It acts like there's food in the water, right? So naturally it would be now producing its own glutamate.
Right, inside, yes.
I can give it haloperidol, which blocks dopamine, and it still runs around just as much as if it had been smelling the food.
Really?
I don't know if this would continue in a longer term project. So one thing that I've seen in a couple of bits of research that tends to be downplayed is after you give something haloperidol, there seems to be an initial excitatory phase. So when something gets haloperidol, at first it's getting no carrots, so it really wants carrots. And so at first it'll push that button a little bit faster, and then it will give up. And so I might have been only doing my experiments on crayfish in that initial bit. And so initially, haloperidol has no particular effect because there wasn't that much dopamine anyway. Right, there was only little tiny carrots in that crayfish donkey brain, and so by blocking it, it still wants stuff. It's still seeking. How it knows what to want, I don't know. I'm wondering if there aren't more than one reward. We know there's these two other molecules. It might be getting small amounts of cannabinoids. It might be getting small amounts of opioids. So there might be more than one reward and desire pathway. We know that people who are blocked from getting, say, heroin, really, really want more heroin. And that is a measurement of reward based on opiates. Now, opiates are, again, related to dopamine. So the current model is all of that wanting for heroin is coming from wanting triggered by dopamine that is then satisfied by the presence of opium. Okay, so the idea is that the wanting has nothing to do with the opioids. I disagree. I think all the rewards are rewards.
That kind of intense wanting is only created by the presence of the opioids.
Well, by the lack, by what you used to have and now you lack it.
But it's only created by the initial elevated level, which is then a renormalization.
Right.
And then the lack.
Right. So the model of wanting being a separate function from liking, I disagree with. I think the more you get what you like, the more you want it. And so
that just seems like
exactly my model is simpler.
Like that,
my model is simpler.
It's like, why would that not be so?
Right. So some of the arguments against this is if someone is a cocaine addict and you block dopamine, it reduces their cravings for cocaine, but they're still happy to ingest the cocaine when they get it. So just like the rat given haloperidol.
Yeah.
However, it never lasts. It never works because there is this more or less constant lack of cocaine, which even if you are not feeling the wanting associated with dopamine, for somehow you still want it. So I think the dopamine is a larger signal for desire, but that the opioids and the cannabinoids are also rewards and also signals of desire.
How could anything be only one thing when everything in life tells us that everywhere we look, nothing is any one thing?
Well, it's true. And it's no matter what model you use, you have to be able to go back and forth between wanting and the gratification of the thing you want.
But also, it's fascinating. I mean, the first time you told me that dopamine actually directly just turns into epinephrine, it's like, but so one thing is literally not one thing.
Right.
It literally becomes something else after it's been in the body long enough.
Right. So the dopamine is the reward, and epinephrine is the stimulant to move towards the reward. And so if you have a little bit of dopamine, it's turning into a little bit of epinephrine and you move towards it. Now, no matter what model you use, once you start defining things strongly in a model, there's going to be problems with your model. But I think I'm answering more of the problems with the existing model, with my model, than the one where you're separating dopamine as not a liking drug, it's a wanting drug purely. One of the things that makes more sense in my model than in the existing one is ADHD. So the current model of ADHD is you're hyperactive because you have a low amount of dopamine. So if dopamine is a stimulant, then more dopamine would not be recommended. Whereas if dopamine is inhibitory and you give someone who has ADHD dopamine, they're going to be able to concentrate better. And this is what we actually do, right? So when people have ADHD, we give them stimulants that stimulate dopamine.
Yes.
And that dopamine
I never realized this. The stimulants, what they do is they stimulate dopamine.
Yes, exactly.
I didn't realize
the amphetamines. Exactly. And yes, you get stimulated because some of that dopamine is turning into epinephrine. And it stimulates you.
There will be activity.
And it will be activity. And this holds true for ADHD people as well as anyone else. There's some people out there who think that somehow stimulants don't affect ADHD people. That for whatever weird reason in their brain, that stimulants are inhibitory to ADHD people. It's not true. Stimulants are stimulating because of epinephrine. Your heart will go faster, your appetite will be reduced, all of these things. However, the dopamine is making you feel like you've found the thing you're looking for. And so you stop some of that seeking behavior that is associated with low dopamine. So in that appetitive cycle that we were talking about, people who have ADHD are always in that part where they're a little uncomfortable and they're starting to look for that next sets of rewards.
Whatever that is. No idea what it should be.
And this is the weird thing about our brains is we don't know one dopamine from another. Yeah. So, we can transfer one kind of reward for another. So when we're depressed, we eat lots of food because it makes us feel better because we get those rewards, and we're less depressed. All of these things.
Yeah.
So this is what people with ADHD are always looking for. And also, I think why they can hyperfocus. So one of the sort of superpowers of ADHD is, yes, you have lack of focus. You're always looking for other things. But when you really get into things, you see nothing else in the world.
The whole world disappears.
And I think what's happened is you've triggered that dopamine reward. When you found something you really like, you get into it even deeper than other people have because you've been so seeking that now you've found your reward. And again, it can be anything. It's not, you could become a drug addict, or you could become a painter, or it could be anything that gives you that satisfaction. There is no difference to the dopamine. It's all the dopamine. But fundamentally, I think dopamine is an inhibitory reward. It is not stimulatory, and that it is something where you need small amounts to move towards a goal. But it is still the reward given to you with the goal. It works with other rewarding molecules, the cannabinoids and the opiates, but it itself is also a rewarding molecule and acts just like them. When you get a big reward, you sit still and just smile, right? That's what dopamine does, and that's what cannabinoids do, and that's what the opiates do. And when you don't have those things, you start seeking them. This is what all of these things do. And so I think rewards are the measure of the wanting. Okay.
The rewards are the measure of the wanting.
Yeah, so the bigger the reward, the more you will want it. If you see a bigger carrot out there, you're going to want it more.
Fascinating.
All right, so that was basically my talk for today. It was a short one.
So, but what you've done though, before I let you finish, you've turned it around. It's the measure of the wanting, not the measure of the reward.
Right. So that wanting, yeah. I mean, so previous to this, it would be something that gave you a lot of dopamine could make you want something, but then you might not enjoy it when you got it. In this model, when you really enjoy something, it makes you want it.
Makes you want it that much more.
That much more,
Yeah,
exactly.
yeah.
And to me, that makes much more sense.
Yeah. Everything you've been saying just seems to make sense. All right. Well, yeah. Thanks, Josh. That was fascinating.
Yeah, just a quick rundown on where I'm going and what my next semester is going to be, and then I'm going to start doing some experiments, and I'll have some more answers. But this is going to take years.
So I mean, that was my next question: is how do you find results that prove what it is that you're saying? Like,
well, nothing is ever proven, but I can show things in that'll support my ideas. And the main one is that dopamine is not stimulatory.
I love it.
And I can show it again and again and again.
So then, am I sitting here hearing the genesis of the work of many students to come?
Yes.
Oh, I love it.
Absolutely. Yes.
I love it.
This is going to be years of work.
Fantastic. All right. Have fun, everyone. All right.
Thank you.
Thanks, Josh.